Here I am going to discuss about three-phase energy meter working and construction. And what is a three-phase energy meter? An energy meter that is used to measure energy consumed in kilowatt hours, and this is used in each and every house and industry for calculating energy consumed by them. And a three-phase energy meter has same element as in case of a single-phase energy meter. Okay, now we will see the construction of a three-phase energy meter. The three-phase energy meter mainly consists of a driving system, a moving system, braking system, and registering or counting system. Okay, and here you can see in the diagram, here एक driving systems are there, and a moving system are there, braking system for breaker magnet, and a registering or counting systems are there. Okay, now we will see one by one. First one is a driving system. What is a driving system? Driving system, it consists of a coil wounded on the central limb of a shunt electromagnet which act as a pressure coil, or it is also known as the voltage coil. Okay, this is the central limb, and here we are wounded a coil, and this is the shunt magnet, and this is the series magnet of the energy meter. Okay, and this is known as the voltage coil, and this coil, it has some inductance, which means that the inductance to the resistance ratio of coil, that will be very high, and because of this inductive effect, the current flux will lag behind supplied voltage by 90 degree. Okay, and then a copper shading bands are provided on the shunt. Here you can see this is the copper shading bands that is provided at the shunt magnet central limb to get a 90-degree phase angle displacement between the magnetic field that's set up by the shunt magnet and the supply voltage. Okay, and here we have another a series magnet on which the current coil is wound. Okay, and in the series magnet consists of only two limbs, and the current coil that is in series with the load, so that the current will flows through this, and the flux produced at the series magnet, that will be proportional to the load current. Okay, and the driving system of normally three-phase energy meter, it comprise of these elements: shunt magnet and series magnet, and the shunt magnet is known as the pressure coil, and series magnet, the flux is proportional to the load current. Okay, now next we will see what is a moving system. And in moving system, on a vertical spindle or a shaft, a light rotating aluminum disc, here you can see this is the aluminum disc, is attached. With the help of a gear arrangement, the aluminum disc is attached to clock mechanism on the front side of the meter, which helps to, this is the aluminum disc, and it will connected to the counter or clock side, which helps to measure the energy consumed by the load. And here eddy currents are induced due to the varying flux produced by series and shunt magnet. A driving torque is set up due to interaction of these two magnets, that already we have told in single phase energy meter, and therefore the number of rotation of disc, that means this aluminum disc is rotating, that is counted by a counter or clock using a counter circuit. How many number of rotation of disc, that will be proportional to the energy consumed by the load in a certain time of interval, and it is measured in the kilowatt hour. Okay, now next is braking system. Why we are using braking system? For braking, here we are using a breakery magnet. This is the breakery magnet, and the aluminum disc is placed between these two breakery magnet. And why we are using braking system? To damp aluminum disc, we keep a small permanent magnet that is diametrically opposed to both AC magnet or shunt magnet and series magnet. Now this disc move in the magnetic field whenever the aluminum disc it will rotate, already magnetic field is there that will cross the air gap. That's why it will induce a eddy current in this aluminum disc, which interacted with the magnetic field, and it produces a braking torque. And the speed of that rotating disc, that means aluminum disc, that can be controlled by changing the position of brake magnet. Now next is a counting system. Counting system means it has a gear system to which a pointer is attached in counting system. Okay, and this connected to aluminum disc which drives this pointer, and the pointer moves on the dial and gives the number of times the disc is rotated, that is marked by the counting system. Okay, this is the construction of a three-phase energy meter. Now here a three-phase induction motor arranged in different way, and here you can see this is a 2-element three-phase energy meter, and here you can see one common spindle and two discs are there. Okay, these are the disc, this yellow color, and one common spindle. This is the spindle, this is the spindle, and these are the disc. Okay, and two discs are mounted, and each disc have its own brake magnet. This is the brake magnet. Okay, now moving system drives a gear, and each unit provided with its own copper shading ring, shading band, friction compensator, etc. to make the adjustment of obtaining correct reading. Okay, means here two systems are there. That's why it is known as 2-element three-phase energy meter. Now we will see working of a three-phase energy meter. Now we will see how a three-phase energy meter will work. And for some power or energy, the driving torque that should be equal in both elements, because here two elements energy meters are there, and for adjusting in both the torque in both the elements, we have two current coil connected in phase opposition and two potential coil in parallel. In the diagram you can see that here two current coil and two potential coils are there. Current coil is indicated by CC and potential coil is indicated by PC. And now for and here the two potential coil that are connected in parallel, and full load current that passes through the current coil, and this arrangement causes two torque to be opposition, and the disc doesn't move if torques are equal, because in single phase we have seen because of the flux produced at the current coil and potential coil, it will produce a torque. Because of interaction between the torque, the disc will rotate. But here two potential coil and two current coils are there, that's why because of that torque it will not it does not move if the torques are equal. And the magnetic shunt, that means the voltage coil, that is adjusted if there is a inequality in torque to make the disc to stand still. Before testing three-phase energy meter, torque balance is obtained by this way. Okay, and aluminum discs are acted upon the two coils. One is voltage coil and another is current coil, and that voltage coil that produce a magnetic flux that proportional to the supply voltage, and current coil that are connected in series with the coil or series with the supply. That's why the the flux is proportional to the load current. And here the voltage coil lags 90 degree by using here a copper ring. Okay, and due to this two torque, then what happened, see here eddy currents are produced in the aluminum disc, because in that disc are placed between a braking magnet, and the disc will rotate on a common shaft, and a force exerted on the aluminum disc, that is the product of current and voltage, and this shaft gear arrangement is made and a needle is attached to this gear. That's why whenever the aluminum disc is rotated, correspondingly the number of rotation, the counts of number of rotation of the disc, that is indicated by the pointer on the pointer attached to the disc in the aluminum coil. Okay. Now, a permanent magnet here we are used to produce a force in opposition and proportional to the speed of the disc. When a power is switched off, this acts as a brake and make this disc to stop rotating. Okay. That is the use of permanent magnet here. Now we will see how we are calculating the instantaneous power. For the instantaneous power, the disc rotate at a speed that is proportional to the power consumed. Okay, then we can write the instantaneous power Pa is equal to 3600 into speed into T into R, where Pa is the real power and T is the time for the disc to rotate through a n rotation. Okay, how much time it will take for n rotation, and n is the number of rotation, and where R is the number of revolutions per kilowatt hour of the meter bay. Okay, so that we can find the instantaneous power by using this formula. Okay.